Hello, and welcome to the introductory lesson of the Certified Six Sigma Green Belt course offered by Simplilearn. This lesson provides an overview of the Certified Six Sigma Green Belt, or CSSGB course. The next screen shows the key features of Simplilearn. Before you start, please spend some time and go through the key features of Simplilearn displayed on the screen. Let us look at the objectives of this course in the next screen. After completing this course, you will be able to discuss the basics of Six Sigma, describe the activities of the define phase, and explain the tasks performed in the measure phase. You will also be able to perform data analysis and hypothesis testing in the analyze phase. Finally, you will be able to identify the possible improvement actions for the performance of variations in the improve phase and define efficient operating levels for KPIV and KPOV in the control phase. Let us learn about Simplilearn's CSSGB course in the following screen. Simplilearn's body of knowledge, or BOK, aligns with that of American Society of Quality, ASQ, the premier training agency worldwide in Six Sigma. The table of contents, or TOC, covered throughout the course is aligned with the ASQ TOC version, which is due to be released in December 2014. In the next screen, we will get an overview of the Six Sigma course. Six Sigma is an industry-neutral discipline and can be applied to 70 different sectors. Some of the examples are IT, manufacturing, healthcare, defense, radio and telecommunications, and banking and finance. Six Sigma is a highly disciplined management tool with a statistical, analytical, and data-driven approach. It focuses on developing a process, eliminating the defects, and consequently delivering quality products and services consistently. For professionals, Six Sigma Green Belt is the first step of the professional Six Sigma certification. The Six Sigma Green Belt certified individual functions under the supervision of a Six Sigma Black Belt. After completing CSSGB, a professional will be able to use basic statistical tools and complete short-run LOB, line of business, product line, business process, or service projects. Let us look at the target audience and course prerequisites in this screen. Target audience. This exam is designed for professionals who work in process improvement teams, solve problems related to quality, and work closely with Six Sigma, Lean, or other quality improvement projects. Course prerequisites. Candidates must have at least 2 to 3 years of work experience in any niche or sector. Let us understand the value of CSSGB for professionals in the following screen. As a professional, you can benefit from CSSGB in the following ways. Demonstrate knowledge of Six Sigma tools and processes. Assist with data collection and analysis for Black Belt projects. Lead Green Belt projects or teams. Solve any problem with data and analytics. Help in identifying the gaps in a process and fix them. Let us understand the value of CSSGB for organizations in the following screen. Organizations can benefit from CSSGB in the following ways. Identify the root cause of problems. Eliminate defects in a process. Avoid process variation and waste. Standardize the process. Address the key business requirements. Gain competitive advantage. Let us take a look at the lessons covered in this course in the following screen. There are 6 lessons in this course. Please spend some time to go through the breakup of each lesson, along with the details of the topics covered in each lesson. In addition to these lessons, there are 2 case studies with exercises provided for your reference. This screen provides details of the exam pattern. The CSSGB exam measures the comprehension of CSSGB Book of Knowledge. There will be multiple choice questions with multiple answer options given, wherein the right answer must be selected. The total number of questions will be 100. The possible number of questions per lesson is listed on the screen. Please go through the same. In the next screen, let us learn about CSSGB exam. This screen provides details of the exam pattern. The CSSGB exam measures the comprehension of CSSGB Book of Knowledge. There will be multiple choice questions with multiple answer options given, wherein the right answer must be selected. The total number of questions will be 100. The possible number of questions per lesson is listed on the screen. Please go through the same. In the next screen, let us learn about CSSGB exam. CSSGB exam details are as follows. It is an open book exam. Participants are allowed to refer to the training module, online sources, and tables as prescribed by the facilitator. In the United States, the exam is conducted throughout the year. Details of locations and dates are available on the ASQ website. For locations other than the United States, the exam is conducted in 66 countries by international certification affiliates of ASQ in June and December. Other exam details can be found at the ASQ website shown on the screen. Simplilearn's CSSGB examination can be taken anytime post-completion of the CSSGB training program. Let us learn about the Six Sigma Green Belt certification in the next screen. CSSGB proves that certified professionals can analyze and solve problems related to quality and can be involved in quality improvement projects. The exam title is Certified Six Sigma Green Belt, or CSSGB. The exam duration is 4 hours. There are no prerequisite certificates required to take up this exam. The Certified Six Sigma Green Belt course provided by Simplilearn can be taken up to prepare for the certification exam. Let us look at some useful sources of information in the next screen. Some of the websites that provide CSSGB certification preparation materials and reference books are listed on the screen. Hello and welcome to the first lesson of the Certified Six Sigma Green Belt course offered by Simplilearn. This lesson provides an overview of Six Sigma and the organizational goals. Let us look at the objectives of this lesson in the next screen. After completing this lesson, you will be able to describe the basics of Six Sigma and organizational goals. You will also be able to explain lean principles in the organization and design for Six Sigma. Let us start with the first topic in the following screen. In this topic, we will discuss the basics of Six Sigma and organizational goals. Let us start with an introduction to Six Sigma in the following screen. Six Sigma is a highly disciplined process that focuses on delivering near-perfect products and services consistently. Its strength is that it's a continuous improvement process with an unwavering focus on change empowerment, seamless training of resources, and continuous top management support. These three are known as the pillars of Six Sigma. If Six Sigma is implemented methodically, it will give sustained results for any process. Now the question arises as to what is a process. This will be explained in the next screen. A process is a series of steps designed to produce a product and/or service according to the requirement of the customer. A process mainly consists of 4 parts: input, process steps, output, and feedback. Input is something put into a process or expended in its operation to achieve an output or a result. For example, man, material, machine, and management. Output is the final product delivered to an internal or external customer. For example, product or services. It is important to understand that if the output of a process is an input for another process, the latter process is the internal customer. Each input can be classified as controllable, represented as C, non-controllable, represented as NC, noise, represented as N, and critical, represented as X. The most important aspect of the process is the feedback. As can be inferred from the image, any change in the inputs causes change in the output. Therefore, Y equals F of X. Feedback helps in process control because it suggests changes to the inputs. Let us learn about the process of Six Sigma in the next screen. Let us understand how Six Sigma works in this screen. Six Sigma is successful because of the following reasons. Six Sigma is a management strategy. It creates an environment where the management supports Six Sigma as a business strategy and not as a standalone approach or a program to satisfy some public relations need. Six Sigma mainly emphasizes the DMAC method of problem solving. Focus teams are assigned well-defined projects that directly influence the organization's bottom line with customer satisfaction and increased quality being byproducts. Six Sigma also requires extensive use of statistical methods. The next screen will focus on some key terms used in Six Sigma. Let us look at the Sigma level chart in this screen. As discussed earlier, the Six Sigma quality means 3.4 defects in 1 million opportunities, or a process with a 99.99966% yield. The Sigma level chart given on the screen shows the values for other Sigma levels. Please take a look at the values carefully. Let us understand the benefits of Six Sigma in the next screen. The organizational benefits of Six Sigma are as follows. A Six Sigma process eliminates the root cause of problems and defects in a process. Sometimes the solution is creating robust products and services that mitigate the impact of a variable input or output on a customer's experience. For example, many electrical utility systems have voltage variability up to and sometimes exceeding a 10% deviation from nominal value. Thus, most electrical products are built to tolerate the variability, drawing more amperage without damage to any components or the unit itself. Using Six Sigma reduces variation in a process and thereby reduces waste in a process. It ensures customer satisfaction and provides process standardization. Rework is substantially reduced because one gets it right the very first time. Further, Six Sigma addresses the key business requirement. Six Sigma can also be used by organizations to gain advantage and become world leaders in their respective fields. Ultimately, the whole Six Sigma process is to satisfy customers and achieve organizational goals. In the next screen, let us understand Six Sigma and quality. Taking a process to Six Sigma level ensures that the quality of the product is maintained. The primary goal of improved quality is increased profits for the organization. In very simple terms, quality is defined as the degree of excellence of a product or a service provided to the customer. It is conformance to customer requirement. If the customer is satisfied with the product or service, then the product or service is of the required quality. Let us look at the history of quality in the next screen. In the mid-1930s, Statistical Process Control, SPC, was developed by Walter Shewhart and used extensively during World War II to quickly expand the U.S.'s industrial capabilities. SPC is the application of statistical techniques to control any process. Walter Shewhart's work on the common cause of variation and special cause of variation, assignable, has been used proactively in all Six Sigma projects. The approach to quality has varied from time to time. In the 1960s, there were quality circles, which originated in Japan. It was started by Kaoru Ishikawa. Quality circles were self-improvement groups composed of a small number of employees belonging to a single department. Quality circles brought in improvements with little or no help from the top management. In 1987, ISO 9000 was introduced. ISO stands for International Organization for Standardization. ISO 9000 is a set of international standards on quality management and quality assurance to help organizations implement quality management systems. ISO 9000 is still in effect. Baldrige Award, now known as the Malcolm Baldrige National Quality Award, was developed by the U.S. Congress in 1987 to raise awareness of quality management systems as well as recognize and award U.S. companies that have successfully implemented quality management systems. In 1988, another quality approach was developed known as benchmarking. In this approach, an organization measures its performance against the best organizations in its field, determines how such performance levels were achieved, and the information is used by the organization to improve itself. Then in the 1990s, there was the balanced scorecard approach. It is a management tool that helps managers of all levels to monitor their results in their key areas so that one metric is not optimized while another is ignored. During the year 1996 through 1997, an approach known as re-engineering was developed. This approach involved the restructuring of an entire organization and its processes. Integrating various functional tasks into cross-functional processes is one of the examples of re-engineering. In the next screen, let us find out about the quality gurus and their contribution to the field of quality. Let us focus on Six Sigma and the business system in this screen. Business systems are designed to implement a process or a set of processes. A business system ensures that process inputs are at the right place and at the right time so that each step of the process has the resource it needs. A business system design should be responsible for collecting and analyzing data so that continual improvement of its processes, products, and services is ensured. A business system has processes, sub-processes, and steps as its subsets. Human resources, manufacturing, and marketing are some examples of processes in a business system. Six Sigma improves a business system by continuously removing the defects in its processes and also by sustaining the changes. A defective item is any product or service that a customer would reject. A customer can be the user of the ultimate product or service, or can be the next process downstream in the business system. Let us learn about Six Sigma projects and organizational goals in the following screen. Let us understand the structure of the Six Sigma team in this screen. There are totally 5 levels in the Six Sigma screen. The first level consists of the top executives of the organization. These people lead change and provide direction as they own the vision of the organization. For any improvement initiative to work, it is important that top management of the organization be actively involved in its propagation. The top executives own the Six Sigma initiatives. Next in the level are Six Sigma champions. They identify and scope projects, develop deployment and strategy, and support cultural change. They also identify and coach Master Black Belts. 3 to 4 Master Black Belts work under every champion. Six Sigma Master Black Belts train and coach Black Belts, Green Belts, and various functional leaders of the organization. They usually have at least 3 to 4 Black Belts under them. The fourth level in Six Sigma structure is Six Sigma Black Belts. They apply strategies to specific projects and lead and direct teams to execute projects. Finally, there are Six Sigma Green Belts. They support the Black Belt employees by participating in project teams. Green Belts play a dual role. They work on the project and perform day-to-day jobs related to their work area. In the next screen, we will understand the drivers and metrics of organizational strategy. While financial accounting is useful to track physical assets, the Balanced Scorecard, or BSC, offers a more holistic approach to strategy implementation and performance measurement by taking into account perspectives other than the financial one. For an organization, traditional strategic activities that concentrate only on financial metrics are not sufficient to predict future performance. They are not sufficient to implement and control the strategic plan either. BSC translates the organizational strategy into actionable objectives that can be met on an everyday basis and provides a framework for performance measurement. The balanced scorecard helps clarify the organizational vision and mission to workable action items to be carried out and measured. It also provides feedback on both internal business processes and external outcomes. By doing so, it enables continuous improvement in strategic performance toward achieving organizational goals. The balanced scorecard achieves all this by integrating the organizational strategy with a limited number of key metrics from 4 major areas of performance: finance, customer relations, internal processes, and learning and growth. Many organizations in the world use balanced scorecard approaches, and the number is increasing every day. In the next screen, we will describe the balanced scorecard framework. We will learn about developing a balanced scorecard in this screen. While applying the balanced scorecard in an organization, care must be taken to account for interactions between different perspectives or strategic business units and avoid optimizing the results of one at the expense of another. To outline the strategy, a top-down approach is followed by determining the strategic objectives, measures, targets, and initiatives for each perspective. The strategic objectives refer to the strategy to be achieved in that perspective. 3 or 4 leading objectives are agreed upon. The progress toward strategic objectives is assessed using specific measures. These measures should be closely related to the actual performance drivers. This enables effectively evaluating progress. High-level metrics are linked to lower-level operational measures. The target values for each measure are set. The initiatives required to achieve the target value are identified. As already mentioned, this exercise is carried out for all the perspectives. Finally, the scorecard is integrated into the management system. In the next screen, let us understand the change in the approach to the balanced scorecard from the 4-box model of BSC to strategy maps. In earlier approaches to the balanced scorecard, the perspectives were presented in a 4-box model. This kind of scorecard was more a comprehensive glance at the key performance indicators or metrics in different perspectives. However, the key performance indicators or metrics of different perspectives were viewed independent of each other, which led to a silo-based approach and lack of integration. However, modern scorecards place the focus on the interrelations between the objectives and metrics of different perspectives and how they support each other. A well-designed, balanced scorecard recognizes the influence of one perspective on another and the effect of these interactions on organizational strategy. To achieve the objectives in one perspective, it is necessary to achieve the objectives in another perspective. In short, the 4 perspectives form a chain of cause and effect relationships. A map of interlinked objectives from each perspective is created. These objectives represent the performance drivers, which determine the effectiveness of strategy implementation. This is called a strategy map. The function of a strategy map is to outline what the organization wants to accomplish and how it plans to accomplish it. The strategy map is one-page view of how the organization can create value. For example, financial success is dependent on giving customers what they want, which in turn depends on the internal processes and learning and growth at an individual level. In the next screen, we will look at the impact of the balanced scorecard on the organization. The balanced scorecard and strategy map force managers to consider cause and effect relationships, which leads to better identification of key drivers and a more rounded approach to strategic planning. The BSC enables the organization to improve in the following ways. Being a one-page document, a strategy map can easily be communicated and facilitates understanding at all levels of the organization. An organization is successful in meeting its objectives only when everyone understands the strategy. The balanced scorecard also forces an organization to measure what really matters and manage information better so that quality of decision-making is higher. Creating performance reports against a balanced scorecard allows for a structured approach to reporting progress. It also enables organizations to create reports and dashboards to communicate performance transparently and meaningfully. As expected, a balanced scorecard helps an organization to better align itself and its processes to the strategic goals outlined in the BSC. The overall objectives of the BSC can be cascaded into each business unit to enable that unit to work toward the common organizational goal. All the activities of the organization, such as budgeting or risk management, are automatically aligned to the strategic objectives. To conclude, the balanced scorecard is a simple and powerful tool that, when implemented correctly, equips an organization to perform better. Let us proceed to the next topic of this lesson in the following screen. In this topic, we will look at what lean is and how lean is applied to a process. Let us start with the lean concepts in the next screen. Let us look at the process issues in this screen. Lean focuses on three major issues in a process, known by their Japanese names, Muda, Mura, and Muri. Muda refers to non-value-adding work. Mura represents unevenness, and Muri represents overburden. Together, they represent the key aspects in lean. Let us look at the types of waste in the next screen. There are 7 types of muda, or waste, as per lean principles. Let us understand these 7 types of muda. Overproduction. This refers to producing more than is required. For example, a customer needed 10 products and 12 were delivered. Inventory. In simple words, this refers to stock. The term inventory includes finished goods, semi-finished goods, raw materials, supplies kept in waiting, and some of the work in progress. For example, test scripts waiting to be executed by the testing team, defects, repairs, rejects, any product or service deemed unusable by the customer or any effort to make it usable to the original customer or a new customer. For example, errors found in the source code of a payroll module by quality control team. Motion. A waste due to poor ergonomics of the workplace. For example, finance and account teams sit on the first floor, but invoices to customers are printed on the ground floor, causing unnecessary personnel movement. Overprocessing. Additional process on a product or service to remove unnecessary attribute or feature is overprocessing. For example, a customer needs a bottle and you deliver a bottle with extra plastic casing. A customer needs ABEC3 bearing and your process is tuned to produce more precise ABEC7 bearings, taking more time for something the customer doesn't need. Waiting. When a part waits for processing or the operator waits for work, the wastage of waiting occurs. For example, improper scheduling of staff members. Transport. When the product moves unnecessarily in the process without adding value. For example, a product is finished and yet it travels 10 kilometers to the warehouse before it gets shipped to the customer. Another example, an electronic form is transferred to 12 people, some of them seeing the form more than once. That is, the form is traveling over the same space multiple times. Next, we will look at lean wastes other than the 7 types of waste discussed. Some lean experts talk about additional areas of waste. Underutilized skills. Skills are underutilized when the workforce has capabilities that are not being fully used toward productive efforts. People are assigned to jobs in which they do not fit. Underperforming processes. Automation of poorly performing process. Improving a process that should be eliminated if possible. For example, the product returns department or product discounts process. Asymmetry in processes that should be eliminated. For example, 2 signatures to approve a cost reduction and 6 signatures to reverse a cost reduction that created higher costs in other areas. In the next screen, we will look at an exercise on identifying the waste type. We will cover each step of the lean process in the next few screens. In this screen, we will learn about the first step, identify value. To implement lean to a process, it is important to find out what the customer wants. Once this is done, the process should be evaluated to identify what it needs to possess to meet customer requirements. The next screen will focus on the next step of the lean process, value stream mapping. In this screen, we will discuss the differences between push and pull processes. An organization can adopt either of these processes depending on the requirement. Contrary to a pull process, in a push process, the first step is to forecast the demand for a product or service. The production line then begins to fill this demand, and produced parts are stocked in anticipation of customer demand. For example, a garments manufacturer produces 200 shirts based on expected demand, and then waits for customer orders for them. Note that the demand is expected and not actual. Discounts offered to customers by big retailers are examples of the push process. If the garment company adopts a pull process instead, it would start making the shirts only after receiving a confirmed demand from customers. Note that although the pull approach seems better, it is not applicable to all situations. For example, a pharmacy uses a push process. In the next screen, we will learn about theory of constraints. Let us look at an example for the TOC methodology in this screen. The three sub-processes in the packing process are coding or printing, filling, and sealing. The data for the three sub-processes are observed and collected as number of units produced in an hour. The data is as follows. Coding or printing is 900 units per hour. Filling is 720 units per hour, and sealing is 780 units per hour. How can you implement the TOC methodology in this example? Let us build the TOC map for this example. The first step in the TOC methodology is to identify the constraint. Looking at the data, the output per hour from the filling process is 720. This is the constraint in the system. In the second step, the constraint is exploited by analyzing the performance using data. To break the constraint, a repair and maintenance personnel can be assigned to maintain the filling machine on a daily basis. In the third step, the other fixes in the repair and maintenance function are made as subordinate decisions to the one taken in step 2. In this example, carry out the maintenance of the filling machine. In the fourth step, the constraint is elevated by implementing the decisions. In this example, remove the damages from the filling machine. The next step is to go back to step 1 and identify the next system constraint. As per the data collected after implementation of the first cycle of the TOC, sealing can be identified as the next system constraint. Let us now analyze the data before and after TOC implementation in this example. The number of units produced per hour before implementing the TOC in coding or printing process was 900 units. Filling process was 720 units, and sealing process was 780 units. After implementing the TOC, the number of units produced per hour for the filling process increased to 840 from 720 units. Let us proceed to the next topic of this lesson. In this topic, we will discuss the concepts in Design for Six Sigma, or DFSS. Let us first understand DFSS in the next screen. DFSS, or Design for Six Sigma, is a business process methodology that ensures that any new product or service meets customer requirements, and the process for that product or service is already at Six Sigma level. DFSS uses tools such as Quality Function Deployment, or QFD, and Failure Mode and Effects Analysis, or FMEA. DFSS can help a business system to introduce an entirely new product or service for the customer. It can also be used to introduce a new category of product or service for the business system. For example, an FMCG company plans to make a new brand of hair oil, a type of product already in the market. DFSS also improves the product or service and adds to the current product or service lines. To implement DFSS, a business system has to know its customer requirements. DFSS can be used to design a new product or service, a new process for a new product or service, or redesign of an existing product or service to meet customer requirements. Let us learn about processes for DFSS in the next screen. The two major processes for DFSS are IDOV and DMADV. IDOV stands for Identify, Design, Optimize, and Verify. DMADV stands for Define, Measure, Analyze, Design, and Verify. In the IDOV process, the first step involves identifying specific customer needs based on which the new product and business process will be designed. The next step involves design, which involves identifying functional requirements, developing alternate concepts, evaluating the alternatives, selecting a best fit concept, and predicting Sigma capability. Tools such as FMEA are used here. The third step, optimize, uses a statistical approach to calculate tolerance with respect to the desired output. When IDOV is implemented to design a process expected to work at Six Sigma level, this is checked in the optimize phase. If the process does not meet expectations, the optimize phase helps in developing detailed design elements, predicting performances, and optimizing design. The last stage of IDOV is to verify, that is, to test and validate the design, and finally to check conformance to Six Sigma standards. The other process, DMADV, has 5 stages. The first stage is to define the customer requirements and goals for the process, product, or service. Next, measure and match performance to customer requirements. The third stage involves analysis and assessment of the design for the process, product, or service. The next step is to design and implement the array of latest processes required for the new process, product, or service. The final stage is to verify results and maintain performance. In the next screen, we will look at the differences between IDOV and DMADV. The primary difference between IDOV and DMADV is that while IDOV is used only to design a new product or service, DMADV can be used to design either a new product or service or redesign an existing product or service. IDOV involves design of a new process, while DMADV involves redesigning an existing process. In IDOV, no analysis or measurement of existing process is done, and the whole development is new. The design step immediately follows the identification of customer requirements. In contrast, DMADV, the existing product, service, or process, is examined thoroughly before moving to the design phase. The design stage comes only after defining requirements and analyzing the existing product, service, or process. In the following screen, we will learn about Tool Quality Function Deployment, or QFD, which is one of the DFSS tools. QFD, also called Voice of Customer, or VOC, or House of Quality, is a predefined method of identifying customer requirements. It is a systematic process to understand the needs of the customer and convert them into a set of design and manufacturing requirements. QFD motivates business to focus on its customers and design products that are competitive in lesser time and at lesser cost. The primary learning from QFD includes which customer requirements are most important, what the organization's strengths and weaknesses are, where an organization should focus their efforts, and where most of the work needs to be done. To learn from QFD, the organization should ask relevant questions to customers and tabulate them to bring out a set of parameters critical to the design of the product. Apart from understanding customer requirements, it is also important to know what would happen if a particular product or service fails when being used by a customer. It is necessary to understand the effects of failure on the customer to ensure preventive actions are taken, and to be able to answer the customers in the event of failure. In the next screen, we will look at another DFSS tool, Failure Modes and Effects Analysis, or FMEA. Failure Modes and Effects Analysis, or FMEA, is a preemptive tool that helps any system to identify potential pitfalls at all levels of a business system. It helps the organization to identify and prioritize the different failure modes of its product or service and what effect the failure would have on the customer. It helps in identifying the critical areas in a system on which the organization's efforts can be focused. Note that while FMEA enables identification of critical areas, it does not offer solutions to the identified problems. We will look at the varieties of FMEA, such as DFMEA and PFMEA, in the next screen. PFMEA stands for Process Failure Mode and Effects Analysis, and DFMEA stands for Design Failure Mode and Effects Analysis. PFMEA is used on a new or existing process to uncover potential failures. It is done in the quality planning phase to act as an aid during production. A process FMEA can involve fabrication, assembly, transactions, or services. DFMEA is used in the design of a new product, service, or process to uncover potential failures. The purpose is to find out how failure modes affect the system and to reduce the effect of failure on the system. This is done before the product is sent to manufacturing. All design deficiencies are sorted out at the end of this process. In the following screen, we will understand FMEA Risk Priority Number. FMEA Risk Priority Number, or RPN, is a measure used to quantify or assess risk associated with a design or process. Assessing risk helps identify critical failure modes. Higher the RPN, higher the priority the product or process receives. RPN is a product of three numbers: severity of a failure, occurrence of a failure, and the detectability of a failure. All these numbers are given a value on a scale of 1 to 10. The minimum value of RPN is 1, and the maximum value is 1,000. A failure mode with a high occurrence rating means the failure mode occurs very frequently. A mode with a high severity rating means that the mode is really critical to ensure safety of operations. A mode with a high detection rating means that the current controls are not sufficient. In the next screen, we will look at the FMEA table. The FMEA table helps plan improvement initiatives by underlining why and how failure modes occur and helps organizations plan for their prevention. Typically, FMEA is applied on the output of root cause analysis and is a better tool for focus or prioritization as compared to multivoting. One important aspect of FMEA is that it does not need data. Experts in a particular area can form the FMEA table without having to look at data from any source. In functions such as human resources, the FMEA table is very useful, as there might not be much data available to the problem-solving team. The sample FMEA table is given on the screen. Please go through the contents for better understanding. In the following screen, we will discuss severity of risk priority number and scale criteria. Let us first discuss severity. Severity refers to the seriousness of the effect of the failure mode, or how critical the failure mode is to the customer or the process. The severity of a failure mode is rated on a scale of 1 to 10 using a severity table. Different industries follow different structures for the severity table. A high severity rating indicates a mode is critical to operational safety. For example, a team working on FMEA of a radioactive plant may insert fatal as the effect with rating 10. Another example is the severity table for a sports team. The team manager wants to rate the severity of failure of the team in an upcoming game. She might rate it at 9, given that the team would lose a big sponsorship should they face defeat, which could in turn be hazardous to the team's future. Shown here is a generalized table of severity. The severity rating can never be changed. For example, if a mode has a rating of 9 before improvement, it will continue to have a rating of 9 after improvement too. Let us look at occurrence of RPM and scale criteria. Occurrence is the probability that a specific cause will result in the particular failure mode. As with severity, occurrence is rated on a scale of 1 to 10 based on a table. Like the severity table, higher the occurrence of a failure, higher is its rating. Again, this table might vary depending on the industry and scenario. Sometimes the project team can use data here if available. Based on past data, the probability of occurrence of a failure can easily be rated. Shown here is a generalized table. Let us next look at detection of RPN and scale criteria. Detection is the probability that a particular failure will be detected. The table shown here is again a generalized one. The rating here is a bit different from severity or occurrence. Higher the detectability of a failure, lower is its rating. This is because if the failure can easily be detected, then everyone would know of it, and therefore there would be less or no damage. For example, if detection is impossible, the failure is given a rating of 10. Please note that at the start of a Six Sigma project, the failure mode is given a relatively high detection rating. Let us look at an example of FMEA and RPN in the next screen. In this example, a bank wants to recognize and prioritize the risks involved in the process of withdrawing cash from an ATM. It can be observed from the table that not having a control in place for network issues has the highest RPN. This is due to the detectability for a network issue being very low. The next set of information in the table shows the action taken by the bank's management to address the failure modes. Following the implementation, the new RPN is calculated, retaining the security level at 9. This is because the actions were not directed at reducing the severity, but at the causes of failure. It can be seen that the new RPN is much lower, and the risk for both causes has been mitigated. Let us summarize what we have learned in this lesson. Six Sigma follows the DMAC process that focuses on developing and delivering near-perfect products and services consistently. Taking a process to Six Sigma level ensures that quality of the product is maintained, with the primary goal being increased profits. Lean is a continuous process to eliminate or reduce waste and NVAs from a process. DFSS ensures that a new product or service meets customer requirements, and a process is at Six Sigma level using tools such as QFD and FMEA. With this, we have come to the end of this lesson. Let us learn about Define phase in the next lesson.